to EC and Professor Sudip Prasad, who was my colleague earlier, for inviting me to have this particular session for you. So, let me just have some introduction. Can I speak?
Sir, anyone? Sir, can you
So good afternoon to all of you once again. So there are less number of students, right? So but I would like to interact with more the students usually, right? So anyway, so there are faculty members also too. So we can have fruitful interaction with all. So my topic is to be like innovations in renewable energy. So the topic was given by Professor Sudip Prasad. After that, I was just working hard to prepare myself. Since I am working in renewable energy for quite a long time, right? I am working on some project. So he requested me to just speak on some innovation. What are the different technologies, innovative technologies in this direction, right? And what are the top innovations happening in this particular area, right? So without innovation, no technology can sustain. Do you agree with this? Yes. Right? So in the morning session, Dr. Saha, he was also our friend actually, and all we were together. So he rightly pointed out that idea generation, right, innovation, how the product is being developed, right? You using the innovative ideas, right? So there are so many points he highlighted. I don't know how you will be able to catch that particular concept, which is going to be very important as far as the engineering is concerned. Most, right? Not only in engineering, when you just develop a product, it is going to be engineering. So after that, you have to market it, you have to sell it in market, right? And you need to have supply chain network to reach that particular product to the customer. So every stages need to have this particular innovations. Otherwise, the sustenance of the technology or the innovation will not happen, right? So you must be knowing this Paris Agreement, right? So we start with this Paris Agreement. Anybody do know about this student side? Maybe I think faculties may be knowing, but any idea from the student side? So anyway, so why we switch over from non-conventional energy to renewable energy? So that is a question, right? So what are the reasons behind? Because the renewable energy sources are going to be very important, energy. What you can say, the harvesting method, right? Rather than going for the conventional, method, what we have right now. For example, fossil fuels like petroleum. Yes, exactly. So petrol, diesel, and coal. So we have thermal power plant. So these non-renewable energy sources are really harmful to the health of the atmosphere, right? Ecosystem. And there are some other reasons why we are switching over. So the first one is the Paris Agreement. So the Paris Agreement talks about the global warming. So you know about global warming, right? So the carbon dioxide gas, which is coming from the automotive tailpipe, which goes to the atmosphere and it just stays there in the atmosphere, it traps the heat which is coming from the sun. And the heat is maintained in the atmosphere and it makes the global warming. You understand, right? So the earth is getting warm. It is not good, right? That is. So there are 2 points in the Paris Agreement. The number one is holding the average temperature of the globe. So if you just calculate the temperature at different zones on this earth, right, it should not be more than 2 degrees Celsius. So that is number one condition. Number two is putting all efforts to limit the temperature rise below or within 1.5 degrees Celsius. For example, India has to meet this particular requirement of 1.5 degrees Celsius, right? And all other stakeholders, all other countries to completely jointly maintain the temperature of around 2 degrees Celsius. The average temperature of the globe should be 2 degrees, and then 1.5 degrees specific to the zone. So now you understand what is that. So this is these are the two important requirements of Paris Agreement, in which India also has got signed. So almost around 157 countries have signed to become member in this particular Paris Agreement. So this Paris Agreement took place in the year of 2015. So almost 7 years back, everything came. Right? So that is one reason. That's why most of the countries are now pushing this renewable energy, right? And most aggressive way. And the second point is that the depletion of the energy resources. What do you understand depletion? Mean we are now going to see the oil reservoir maybe within 40 years down the line. You will not have oil, you will not have petrol. So how you will run your car? Maybe the generation. So that's why we are just going for electric vehicles, and presently that is coming up. And the natural gas again. So I prepared this slide maybe 3 years back, right? So mostly the trend is same. So after 63 years of time in future, so we will also end up with this the depletion of the natural gas. So still we are producing natural gas, and maybe we have the coal reservoir. It will not get depleted maybe for another 60 to 70 years, maybe more than 100 years. We can survive with this coal, right? So these are the predicted values of each non-renewable energy sources. That's why we have to prepare ourselves to go and harvest the energy from the renewable sources, etc. So the renewable sources, you may be knowing that wind turbine, right? And solar, we have to harvest the solar energy, and hydro is there, hydro power plant, right? So we have to harvest the energy by using water power, and then very important, energy is bioenergy, which is not explored much in India. Though some states are doing fantastic work in bioenergy, but not all states. But plenty of resources are available for promoting this particular bioenergy. But everything is unexplored. So we have to think in that direction to explore more on renewable energy sources. So you see the trend. You can see the trend, right? So this is a fossil fuel. Just how this is declining, and it is projected on till 2030. So we will be going down this particular, and in this case of clean energy, renewable energy, all these energy sources like hydro, solar, wind, right, and biomass. So these are the four major renewable energy sources going up, right? So because of the innovations, very important, right? Innovations in the direction of cost reduction, as Dr. Sajjan pointed out, right? So we have to focus more on the cost reduction. One, and the other thing is that efficiency. So that we will see that, right? So if you calculate the efficiency of a car, petrol car, how much is that? Around 50 to 60%. So it's very costly. Petrol again going up, diesel is going up, right? So these renewable sources of energy should be able to cut down the cost along with the increase in efficiency. So that is the main focus of this particular. Yeah. So that's why we are just moving to innovate on various stages of renewable energy sources. That is various stages mean a component. If you develop, as he pointed out in the morning session, right? The product has to be developed, right? It has to be designed and developed, right? There you have to, sell your ideas, product development. After that, you have to go for manufacturing. Product is manufactured, and then what else? And the product is delivered to the customer, and it goes to the customer. And in customer, the product will be functioning for a long time, right? We will be using, for example, any domestic appliances, right? Refrigerator, air conditioner. So the life of air conditioner may be 15 years, right? After that, what we will do? We will have to throw it away, right? So this particular entire chain is known as life cycle management. I think this is very important aspect. This concept is widely applied in improving the efficiency of renewable energy sources. Right? It's a kind of innovative idea. Innovation means it's not only developing product, it is developing some policies. It is developing some methodology. It talks about some methodology. How the supply chain means the material movement. The AC is manufactured at a factory, and that AC has to be transported to the customers. So that particular supply chain. So it is about the cost saving. So you have to reduce the cost saving throughout the supply chain. So that is called innovation. So innovation has to take place in every stages of the product. That's what R&D from R&D to market scale. It's the market, right? So we apply new smart technologies. We will see all those in detail. And information technology plays a major role, right, in innovating the product. And again, the financial and market instruments and business models, as I mentioned earlier. So you need to focus more on the cost reduction by efficiently, structuring the supply chain. So that is important. So business also play a good role in cost reduction, so that you can sell your product at cheaper rate, right? So that is one way of doing innovation. So these are the key directions. I think it is disturbed. So okay. So fine. So as I mentioned that the reducing direct cost in production. So if you want to manufacture any product, your objective is to reduce the manufacturing cost. Right? If you have startup, ultimately what is your aim? You have to generate the revenue, right? You have to increase their profit. So the manufacturing cost should be less. That is one. And second is the efficiency, improving conversion efficiency. So conversion efficiency means energy conversion. Energy conversion means energy is produced. For example, you are just harvesting the wind energy, which is kinetic energy of the wind, right? It is now converted into electricity, right? So the energy conversion. So that conversion is nothing but the process where the energy is converted from one form to the other form. That is all. So there the machine, wind turbine, plays the magic. So you have to increase the efficiency, right? So by doing some innovation, the methodology. I think it may not be clear. Let me read. So these are the top 10 innovative technologies which are not only applied in renewable energy, but also widely applied in any engineering technology. The number one is photovoltaic. This is very now common, right? Photovoltaic means it's a solar, right? Photovoltaic. So the photovoltaic cell is used for converting the sun rays which is falling on the photovoltaic panel, and then there are cells which converts the you can say photon or light energy which is coming from the sun to electricity. Simple. So there is a photovoltaic cell is there in solar. I think that is a basic idea. So presently you might have seen the solar panels erected somewhere. If you travel by train, even yesterday I saw, right, in a station there was a solar tree which was unmaintained. It is not maintained properly, right? It was not giving any something. So that is innovation, right? So other than that, now presently what energy capacity we have as far as the solar is concerned, around 20%, 22% of the solar energy there is. Whereas we have abundant, solar energy which is falling on, right? It's unused, right? So we have to harvest or we have to convert maybe 50% or more than that, right? Then only you can say that the energy is effective, cost effective and energy efficient. So the people now, the researchers, institutions, all over organizations are working towards achieving that innovation in solar by developing material.
So I have a question that you said you have to move to the solar energy. But as we are living in a country where the most of the people just work on a daily basis. They just go on for one day. They just want for one day. How can move to a particular distance is avoidable? So one-time investment. It's as if setting up a solar energy, a solar panel in a particular home, or running a fan or a light for a particular any kind of electricity. So it's very cost effective to them. So reducing the efficiency by using this, we have to maintain efficiency also, and we have to reduce the play. That's because we can make a this much big play which produces 120 volt, but we have to make it smaller. So in particular home that will get cheaper, and you also maintain the 120 volt also. So reducing the size, so how that we can make this kind of particular seeds for the Indian like the zone which is going on under development. As because from 15 years I have started my journey in particular we are hearing that India is a developing country. We are not particularly.
Yeah. I'll answer. So your point is valid. That's what we are talking about innovation, right? So we are adapting technology in materials management, material development. So earlier we used to have silicon-based material, which is very expensive. So it's not cost effective. Now we are just moving towards organic. Organic means natural fibers. But the efficiency is very good. We will see in detail, right? Just when that slide comes now, you will understand, right? Yeah. So here then the second important technology, AI and big data, right? So processing a small data is very easy, but big data processing is again is our ultimate technology. So we will see how the big data is going to help to increase the efficiency, manage the energy, right? And then distributed energy storage system. Mean the energy which is coming from the grid, electric grid, right? And the energy has to be consumed by the consumers, like we, domestic, industry, etc. Instead of that, the distributed energy system means you will have an energy storage nearby community. For example, this is in some colony of Nagar, you will have an energy storage, a battery inverter. It's a big battery inverter with high capacity. So the energy which is coming from the grid will be stored in the energy converter or inverter. Then that will be consumed without any interruption. So that is a technology. This is a kind of innovation. I think probably in metros it is being tried, but it will definitely eventually it will develop, to move forward to rural area. And then hydro, hydro means we are just taking the water power.
Water dam.
Water dam, right? Dams are built for harvesting hydro. But mostly in India we have a big hydro power plants, but that comes under Ministry of Energy. But now the concept of renewable energy, you just go for a small hydro. So small hydro less than 100 megawatt or less than that, coming under the category of renewable energy sources. So the government is now aggressive to set up n number of small turbines, right? So again, that is kind of innovation. And wind turbine, this technology is well established, but still there are some issues. Like efficiency of wind turbine is around 50 to 60, but that has to be increased. And wind turbine has got a lot of issues with the environment. So we'll see what is that, right? And then bioenergy, as I mentioned that it is not much explored, right? Now India is doing lot of funding, but still because the bioenergy has to come from the rural. The people of the rural should have got the knowledge and the technology, etc. And then the knowledge which you have is not reaching to the rural. So that is what we have, that barriers actually. So the technology development should take place. A lot of innovations are coming up, but ultimately the commercialization is not happening much, right? Even I have got the project in biogas. So we have set up our own plant in our university. So taking consideration of all the issues in the northeast of Assam. So we are trying to solve the issues actually. So we have that. And then grid integration. Grid integration means, grid, what is grid? Grid means the electric lines you see, right, physically, which is coming from the dam or the power station. Line goes in the tower and then there will be transformer. So this is nothing but a grid. Supply, right, distribution. So integration, grid integration means, nowadays we talk about smart grid. Smart grid means you just to use IT, information technology, use computer, software to control various parameters. But it's not happening. That was not happening earlier. Now we have to integrate using advanced IT technology, or as I said, that AI, artificial intelligence, big data. So that is what we call grid integration. Right? Again, this is a new area which is being explored. And green hydrogen. The hydrogen technology is not new. It is not new. Now we have to somehow replace this petrol and diesel. The day will come when we will be running hydrogen engines. Maybe 20 years or 30 years down the line. Even EV also will go off. After EV, hydrogen will come up. Maybe 40 years down the line, we will have all hydrogen vehicles.
So there is also a certain kind of energy which is like moving with the water like H2O2. that breaking down H2O2 is gives oxygen at a particular site and the hydrogen is combust into the energy. So H2O2 is also coming up to a particular
Yeah, that is coming up. The automotive companies are now working on hydrogen actually. So it is happening. When Mahindra have got the project, Maruti is doing the project on hydrogen engine and all. So green hydrogen is nothing but, why it is called green hydrogen? It is not going to impact the environment. Otherwise, we are producing hydrogen using conventional way.
Yeah.
Right? It is emitting lot of CO2. The conventional method of producing hydrogen has got lot of impact on the environment. CO2 is coming up. So ultimately CO2 is global, the greenhouse, the green hydrogen. So that is simply that green hydrogen production will not produce any CO2. Right? The simple electrolysis process. And then robots are being used nowadays. Small robots are used for spy purpose. Normally do that for collecting data, right? For example, drones are used. The drone is a kind of robot, right? Taking data, right, from aerial view or something like that, right? The data. So advanced robots are again used in the energy sector. And then blockchain. You have heard about blockchain? Blockchain technology?
Yes, sir.
Right. Good. So blockchain technology is a database technology, right? It is transmitted from one node to the other node, and it is encrypted. WhatsApp message which is encrypted.
Yeah.
In between nobody can, only sender and receiver can only see. Nobody can track or whatever. That is the beauty of WhatsApp.
It comes from the cyber security part.
Exactly. Now we have to use cyber security in energy. Because in smart grid you are going to use IT, right? Information technology. So data has to be preserved. So where you have to go for blockchain technology. So blockchain is a database actually, which is in the form of encryption. So that is what you call. So nowadays, which is widely explored, and there is a lot of chance for exploring research in this blockchain. Is okay. So these are the 10 top technological innovations happening in energy. So you can see the contribution of whatever the energy the innovations we discussed in the previous slide. So I have put in terms of percentage, right? So most of the contribution towards solar, 19%. So solar energy innovations are coming in. R&D, more fund is coming up from government, from international agencies, right? And artificial intelligence, again hot area, right? And the other one is the distributed energy storage system, and then hydro. So these are the four major areas which contribute to the development of the energy in innovations, right? And there are technologies like blockchain, which is having only less 3%, which is coming up. That's why I told you that a lot of innovations scope is there for doing a lot of innovations.
This is for India or the world?
It is common. That this data we actually I'll tell you. Actually, this data collected from around 5,152, I remember, startup companies. You can imagine, right? So this data is not only from India; it's a global data.
That's percentage from global side.
Yes, exactly. So there are so many good sites, global good site. They have the data of India. They have the data of every country. India in wind power, India in solar. What is our capacity right now? So everything is there. Right. I think this is again solar. You see, in 2010, the cost of solar energy was around 0.38 kilowatt hour per kilowatt hour. For example, US dollars. But that drastically reduced to 0.06 per kilowatt hour in the year of 2022. So why and how? Because of the innovations, right? The innovations in the form of price reduction and efficiency increase. Yeah. And earlier we talked about the supply chain. Maybe 20 years back, we talked about only supply chain materials management. I mean how the material cost can be reduced by just transporting the material, right, and manufacturing the material. But now, most of the researchers are taking place in energy conversion, right? How the energy of the solar cell has to be equal, right? And then finally, what happens? So there is a grid parity. Grid parity means very important. The grid parity we have not achieved grid parity in India. Grid parity I think electrical people may be knowing that. Which means what? The whole world is now moving towards renewable energy. We have to abandon the non-renewable energy. We have to abandon the coal, petrol, diesel. We have to, right? So slowly we have to switch over. Once we switch over, the cost of renewable energy should be less than that of conventional energy. Now how much we are paying for per unit? Maybe 10 rupees for example average. So when the complete if you are going to harvest the energy fully from renewable energy sources, the cost should be around 2 rupees, 3 rupees, which is less than that of the cost which we are paying for the conventional.
So it is a drastic case from 10 to 2.
No, I am just giving example. Even if you are able to achieve 1%, it is we have achieved grid parity. So India is now striving to achieve grid parity, right? So everything is possible only to achievement of innovation knowledge. So I put all these slides, just materials. No need to just read this all. So as I mentioned that solar cell is made up of what is that material? Silicon, which is inorganic. Silicon is inorganic, no? Semiconductor, which we use in transistor in the laptop and all, is very expensive. That's why the solar installation cost, as you told, no, it's very expensive.
It's very expensive.
Yeah, that's why the most of the industries and the research organizations are working towards achieving the efficient or cheaper product with good efficiency. So I have put all the technical issues like perovskite, organic solar. As I told you, we are having inorganic cell. Now we are moving towards organic. Organic means natural fiber, but the efficiency is very poor. So eventually the development will take place. Maybe 10 years down the line, the efficiency will also come. Right? And so these are the quantum dots, which is another important innovation. Quantum dots mean about nanotechnology. Nanotechnology. So you make a nanoparticles of the organic or inorganic material. So nano has got efficient, processing ability and all. So we are using nanotechnology in case of quantum. So these are the technological innovations in case of solar. Smart grid. So I think I already told you that what is smart grid. So existing grid, you have to integrate with the communication network. Right? Everything is computerized. And there will be IoT, IoT, right? Internet of Things, that IoT. So IoT is much widely used. IoT means different sensors will be used in different location of the grid, and the sensors will collect the data automatically, and there will be central processing unit that will process the data, and that will give you this much energy is needed. You understand, right? You can just forecast the demand of the energy consumption, energy production. So this is the kind of integration, grid integration. That's why we talk about smart grid. It's very new, and also it is extensively explored in R&D nowadays, right? Grid, smart grid technology. And AI, artificial intelligence, and for VRE. VRE means variable renewable energy. So AI for variable renewable energy. What does it mean? Variable renewable energy mean?
It's about many kinds of renewable energy.
No. This solar is variable. Are you getting the solar energy every day? No, night time you will not get, right? During night the solar will not act, will not get energy. So it is very, So maybe in the noon at 1 p.m. the sun is at top, you will get most of the intensity of the sun, right? Ultimately. But when you just move down 6 o'clock, 6 p.m. or in the morning 6 p.m., 6 a.m., the intensity of the sun is low. So accordingly the energy is produced, right? So that is very, from 6 a.m. to 6 p.m. So the curve will go like this, sun intensity. Accordingly you will get the output of the energy. Is it right? So that is very. The same case, same in wind also. Wind also variable. How I want to say? Exactly. So there should be average wind velocity. I don't know in West Bengal, have you seen that wind turbine and all? You have to explore more, right? Before setting up the wind turbine, you have to see the average wind velocity. Normally that has to be done through the surveyor. If the velocity is low, ultimately it is meaningless to put a lot of money on investing a huge structure and a very expensive, project setting up wind turbine. Right. So in that case, we have to depend on AI. Artificial intelligence is very, very interesting technology, right? AI. Nowadays, even every algorithms behind your computer, Google may have AI, WhatsApp may AI, everything. So AI will check your visit of websites. If you just Google it, from morning to noon, so many websites you have visited. So AI is now just tracking your visits, right? Everyone has to be mindful about this, and that will give you your interesting website. That AI will study the 50 websites you visited, and it will calculate or it will just interpret your interest, and finally it will give you the beautiful website which you are looking for. That is happening in Google, right? So here in variable energy, you have to use AI to predict the energy demand because it is fluctuating, right? Energy is fluctuating. So you have to predict the energy, and also you have to predict the production, and also you have to predict the demand in market. Accordingly, you can manage. So ultimately, you can optimize, right? Cost reduction, etc. So optimize the energy storage and optimize the market design, etc. Right? So as I told you that I have already explained to you that battery storage, right? So every community will have battery storage system. Yeah, that is going to be in future, right? When we are going to depend on only renewable energy, we will have this distributed energy storage because it needs lot of investment ultimately. Hydro. So as I told you, the small scale hydro is now coming up, right? And PAT technology is coming up. PAT mean, I think mechanical civil engineers may be understanding this. PAT mean there is a pump which can also act as a turbine. The simple technology, right? Pump, right? Water pump, so that can also act as a turbine. Right? Pump is to pump the water, and turbine, you have to rotate the turbine in order to get the electricity. Is it right? Right? So pump can act as a turbine. That's why PAT means pump as turbine. Right? So this is again useful input for you people, right? PAT. So again, new technology, innovation. And fish-friendly turbines. Fish-friendly turbines mean when you just set up a hydro power plant in a dam or river, what will happen actually? It damages the ecosystem, no? The river, right? It damages the living being. That is not even good, right? So instead of having the turbine with the blades, turbine has got a blade, right? A blade, you have to just you have to inject water on the blade, and the blade will be, moved with some force, and then the rotation takes place. And the rotational energy is now transmitted to the generator, wherein you will get the electricity, right? So the rotation of the blade forms the life of the, fish and all. So nowadays, that's why they are going for bladeless. Like bladeless mean screw. Screw, right? There is a screw type turbines are manufactured, right? There is no any projection of the blades. So the in place of the projection of the blades, there will be a screw, right? That screw will be used for generating the water, right? Sorry, electricity. So that is based on the Archimedes principle. I think it is again technical. And then power electronics. Power electronics mean again control system is widely explored nowadays for controlling the hydro turbine, right? So here also you can talk about IoT, AI, etc. And then flexibility technologies. So what does it mean, flexibility technologies mean? You can design the turbine to optimize the efficiency by changing the injection angle, by changing the flow of water inside. So there is a lot of flexibility in designing the turbine. That's what is called flexibility technology. And then finally, digital technology. Right? Again, we talk about machine learning algorithm, AI, right, for doing analysis and all, right? So these are the technologies which we can explore in the hydropower. Wind energy, you can see the diagram figure, right? It's a wind turbine. Have you seen the wind turbine earlier?
In hilly area.
Picture me, na?
In hilly area.
Have you seen really in hilly area here in West Bengal?
Not in West Bengal.
It is there in West Bengal. Yeah. Okay. So it's a huge structure, maybe 25 meter, and you can see the blade length maybe 10 meter. Can you imagine? So erecting the huge structure is not that easy, right? So this is a complex. You can see the man just. You see the man is just standing on the turbine, and he has opened it for doing maintenance activity. It's a big structure, right? So very expensive. So what do you do? Here also you explore AI, because every time the man has to go up and check for maintenance, right? If anything happens in the generator or the gear, there are so many engineering parts. It's difficult to inspect all the items to go there. So here also you use IoT. There are a lot of sensors, vibration sensors, pressure sensors, temperature sensors. Right? You collect the data. There will be a processing unit, and you can just predict the life of the component. Right? So that is one way you can use. So this wind turbine has already explored this AI for maintenance purposes. Right? Artificial intelligence. And also drones can be used for inspecting. That is possible because it is difficult, right? And blade maintenance robots are used to check the blade crack or whatever. Small robots are manufactured and can travel along the blade and check the crack or bend or whatever. So robots are again used. And underwater drones, because these turbines are onshore, right? On the land. Have you seen the turbines offshore? In sea. So there are turbines. India is now we have not got any offshore turbines, but now we are doing the feasibility study. In Gujarat, Government of India has taken up the feasibility study of putting up the offshore wind turbine. Why we are moving towards the sea? What is the reason?
Water waves are continuously coming in one direction.
Land breeze and cities.
Sea breeze. You see, we are just moving towards offshore, which is very efficient. Why? Because the wind velocity is very high in sea. It is true. That's why we are just putting the offshore turbines. Right? And bend twist blades. Sometimes the blade also will twist. The technological, innovations have taken place to design the blade, right, in different material, like composite material or whatever, right? So, if the speed of the wind goes beyond certain limit, the blade will get twisted, so that the speed will come down. Right? It will not allow to rotate at high speed because we have to maintain optimal speed. Right? So there is what you call belt twist blades, and sometimes again another innovation, the wind turbines will not have blades. Can you imagine the blades if the fan without blades? Can you imagine? Not possible. So what happens? The wind turbine structure, it is made in the form of conical shape, and that will rotate as a rotor. So the design, that is again innovation, right? But the efficiency is still low, but still the development is going on. That is what you call bladeless wind turbines. And hanging wind turbines, wherever you see the building structure, you can just mount a small wind turbine. So you will get like solar, you can put at your rooftop, right? Rooftop or solar screen anywhere. The similar way, you can just erect this wind turbine based on the size and the type of the building, etc. Thank you. Wind turbine has a problem, I told you, right? What is the problem? How, in what way it impacts the environment?
From the birds.
Huh?
Birds.
Very good. So that is what is written. Bird killing is very bad consequence of this. It's not good, right? So there are some technologies adopted like radar, GPS, tracking, ultrasonic. So these are the common technologies we use in wind turbine in order to avoid the accident, right? Bird will come and hit, right? And the population of the bird species will go down ultimately, right? So this is another area where the wind turbine research is taking place. Bioenergy, another important energy, bioenergy. So in rural India, anywhere, in early days, how the energy is harvested using biofuel, how we cook, right? We just cook it, right? Like putting the powder we just dry it, है ना? In village अभी भी चल रहा है, उसको dry करते, wall में dry करते, उसको then it is used as a fuel. Just burning, it's a combustion, and it produces smoke which is having carbon, which is not good for health. It's having methane, it's not good for health. So instead of that, now we are going for, we have already gone into bioenergy based on the anaerobic digestion. Biogas. Anaerobic digestion means put the cow dung in a reactor, and let it get composed maybe for 30 years or 40 days, sorry. Right? In the absence of oxygen. उधर combustion के लिए oxygen की जरूरत नहीं है. Right? It will get decomposed. Right? Biogas, sorry, biofuel, cow dung. And ultimately after maybe 30 days or 40 days time, the gas will come, methane will come. That is now technology. That's what you call this modern technology. Now we are implementing, but it is not implemented in full speed because of lack of technological innovation. So in my research, there is a problem with this bio energy is that we have to maintain some temperature limit. Maybe 45 degrees Celsius is a temperature, sorry, not 45, 38 degrees Celsius. 38 to 40 degrees Celsius is a good temperature for the bacteria to survive in there. We have to ensure that survival of bacteria in order to ensure that the digestion is taking place. That is a challenge. So in our project, what we did, we stimulated, we created the temperature artificially by putting the heaters. So that is an innovation what we did. Whereas in Assam we have established, the government of Assam has done a lot of good work of putting biogas plant, but the production of biogas plant is almost zero. Sometimes they get and they cook and then they abandon. It is happening not only in Assam, even maybe in West Bengal. The technological growth is not happening. So in our research lab, so we have innovated for maintaining the temperature. Right, so we are doing the experiment, right, and also we are doing the production plant. So that's one kind of innovation. Right, so this is a typical biogas, bioenergy. A simple reactor, just to put the cow dung, right? 40 days, after 40 days, definitely you will give gas. Right, you can do experiment, right? Not only cow dung, vegetables, right? Domestic waste. Now we have to explore all these things. This is kind of innovation. Otherwise, we cannot survive, right? So, as a domestic, electricity, if you have, demand, how you are going to meet demand? Even in my, house, I have used the solar. It is not possible to, get the electric supply without any interruption. It is not at all possible. So there is always, cut off electricity, and we have to depend on the internet. So self-reliant. Every house will be having this concept. Self-reliant. You have to produce your own energy. And if you produce excess energy, you have to sell it to grid. You have to sell it to government. That is going to happen, right? So that is again innovation, right? And as I told you, green hydrogen. When there is a green hydrogen, there will be blue hydrogen, right? So this is a conventional way. So by reforming the steam and natural gas, you get H2 along with CO2. As I mentioned earlier, that the conventional way of producing hydrogen will give you CO2, which is not acceptable. That's why we are going for electrolysis, which is inefficient at present, but there is an improvement. It's again kind of innovation. But definitely, maybe 20 years down the line, this hydrogen, green hydrogen, going to go in energy sector. Right? So summary, you can see that. If you just visit some site which will give you the entire statistics of energy, all global, all the countries, maybe 200 countries are there. What is their solar capacity? What is their energy wind capacity? how much is their bioenergy. So all the statistics available. So from that I collected this. So there is any trend from 2010 to 19. There is a trend you can see, and mostly bioenergy. Wind is now the ground is wind, right? The yellow is solar. So solar is now picking up, right? Overtaking this wind energy. Sorry. So this is India's capacity. Again, India also is showing the same, right? You see the yellow band, which is showing the solar, right? And then brown is wind, and this purple hydro. So hydro, wind, solar, and then bioenergy. So bioenergy contribution is still less, where you have almost 80% of the energy is unexplored. The resources are unexplored. Right. Mostly the rural India can contribute more on harvesting energy from bioenergy. Right. So that's all
So you can become any industrial base also. So as the population is increasing, we are producing huge amount of waste.
wastages, exactly.
Food and other things.
Exactly.
The setup we are
Yeah. So you can explore food waste. We are going to do in our plan, because in student canteen, no, we are getting a lot of food waste and also vegetable waste, raw vegetable waste, and also we are going to try with rice straw. You know rice straw? West Bengal is famous for rice, no? You know that the cover of the rice. We feed it for cattle, no? Gom or whatever you call it, rice straw. So we are going to experiment with the rice straw also. So there's a huge potential for bioenergy. So anybody want to do project or all, so it's a lot of opportunity.
So you have to plan there.
Yeah. So we have set up our plant in our UC. So we are producing biogas.
That
So we are
is
successful.
That is starting for the university or for the household also.
No, we have now conducting experiments.
Or so it is in the national state.
Yeah. Probably we have to think about the supply chain. How we are going to sell it in the market. We are doing all that.
Commercial value.
Yeah.
That's
Sure.
how you market that product.
Definitely. So that's what, no? You have to focus on every nodes of the life cycle of the product. So that's all from my side. If you have any queries, we can have discussion.
Sir, one question is that in many research work it has been seen that different attack, DOS attack, false data injection attack, whenever it is occurred in a week. So what happened that data is stolen. Which type of data? Suppose suddenly load is increases or decreases, so frequencies decreases. So frequencies decreases. Which type of data removed from the system? How which type of?
No, you are talking about grid, no? Grid. No, So when you just go for a smart grid, ultimately it is going to be working on IoT, right, etc. And definitely the IoT will be capturing the data of various working units, like for example the transformer temperature and the oil level in temperature, right? Because all the people are there to steal the data for doing the research. China is aiming for that. They need a lot of data actually, and they will make a more robust structure of that. So China, the countries those who are more focusing on research oriented. Now China is doing very good work.
And they do not use Google also. They have their own system.
Yeah, for tracking, exactly.
You cannot track, they do not use Google.
Exactly. Because they don't use Google. They are very smart actually. They are very smart. And we talk about smart grid. Definitely they might have reached even beyond that. We don't know. And they won't even disclose. And they publish papers which are, they are not publishing in research.
Even in USA, 90% of the editors of LC paper all Chinese.
Exactly.
You see.
And now China is taking all the talents all over. From India, from Europe, from US, all the talents are in huge demand in China.
All the IEEE papers from China.
Yeah.
All even in LCBR also.
LCBR also. And IEEE, you can say
They don't provide any data also.
Yeah. They will not.
Just dominance of the world.
That's why it is happening during pandemic. It happened.
Exactly.
That is a lesson for us.
That's why it is very difficult for us which type of data.
No, for that now all the nations should unite together, and we have to draw some strategy to overcome the
Chinese equation.
offense of this China. Yes, sir? Sudhir,
It is
sir
all
can
difficult
tell more
to
about that. It's a challenge actually. Some 20 years back, China was far behind India in many things. In number of PhDs produced. Now you see, they are just leaping a thing like this. Thank you so much.
Patents also, patents.
Yeah. Yeah.
Any researcher in bonding carbon in the presence, bonding carbon in the presence of oxygen and in the absence of oxygen, that is aerobic combustion of carbon or the anaerobic combustion.
Anaerobic.
So, aerobic combustion produces ethane, which is
Methane.
so, anaerobic combustion is not harmful, but does it not produce a gas?
No. It produces methane along with CO2 and also hydrogen sulfide. So these are the major components in biogas actually. CO2. CO2 is also coming.
It's not harmful.
No. You see, methane is a gas which we are going to use for cooking, for example. Right? That is a useful gas. And along with methane, we are also getting CO2, which is not good because the CO2 is again harmful. So now we are in the process of separating the CO2 from the methane, and we can store the CO2 and we can use for different purpose. So there is another challenge. We can use the CO2 for as an extinguisher, fire extinguisher, gas you can manufacture. And also the unwanted gas is hydrogen sulfide. But now we are getting that. We are now planning to do some research on it. It's again a challenge. Hydrogen sulfide is not good. It will lead to corrosion of the. Yeah, exactly. Very bad sulfide.
Methane will be used for
Yeah.
methane for cooking.
Exactly. Cooking, and you can generate electricity also by heating the water for producing steam. So that's what now this bioenergy has got a lot of scope for R&D and all. So you people can think about it, being a student. There's something if you do, that is a good contribution. Even little, you do some survey that will help some researchers. Yeah, that's what we are doing. Okay. Right. So any other question?
Thank you so much, sir. I don't think any question is there from the audience. Audience, do you have any more question? So, thank you, sir, once again for your useful informative session. Now, I will request the Vice President of IIC, Professor Dr. K. Hajan, please come over here to give the certificate of appreciation to Dr. Loganathan. Please come.
Let me introduce them first. Professor Dr. Shantanu Datta was awarded his PhD by NIT Durgapur in 2020 from AV Department, MTech degree by NIT Durgapur in the year 2014 from AV Department, and his BTech was awarded by North Bengal University, Jalpaiguri Government Engineering College in the year 1996 from AV Department. He also obtained his PGDM from Indian Institute of Material Management in 2002 in the domain of supply chain and organization behavior management. Dr. Datta has total academic experience of 11 years, of which he has worked 8 years as assistant professor, and since April 2022 he is working in the capacity of professor in Elitte College of Engineering, Shodhpur. He also has a research experience of around 1 year working in the capacity of GRA and Master of Science researcher in IIT KGP. He was awarded SRF scholarship from Government of India and Central Railway Research IIT KGP in 2011. JRS scholarship from Naval Institute Research Board, New Delhi, Government of India. He has published 35 international research papers till date in reputed international conference in India and